So we're looking at day 2 of the practice test. Remember, this is concept byte and 6.1, 6.2, and 6.3. So it does go back a little ways. And we did the front page yesterday, so we'll do the second page today. And you want your power chart handy, calculator, and again, hopefully this will be much more of you and much less of me as we go through it, since this stuff especially is the thing. These are the things we've done within the last week and a half or so, so hopefully they'll come back to you a little easier. Simplify each expression. Rationalize any denominators when needed. Assume that all variables are positive, which means don't worry about absolute value bars, which is kind of nice. So, 13. What do you think? Could we reduce that if we made it one big fraction? Well, then we better do that. That'll make it a lot easier. So two things that say, hey, simplify me first, would be taking 64 and dividing it by 4 and realizing, oh, that's going to go in there 16 times. And then we notice that the x's and y's, there's two sets of them. And so that means we have to remember how to divide similar bases. What do you do with the exponents when you divide similar bases? You do subtract. So 5 minus 1 will be x to the 4th, and then 3 minus a negative 5. We have to be careful with that one. What will that be? And then you should notice, hey, that looks just like the stuff we did yesterday. So once we get it to this point, we say, all right, numbers behave differently than variables, and this is square roots, so let's go ahead and break that up into perfect squares. Same thing with our y's. So grand total of 4 of those x's for x to the 4th, and then 1, 2, 3, 4 y squareds, taking the square root of those. So then we get 4x, x, y, 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 y. And what will that be all prettied up? That's what it'll be. 4x to the 2nd, y to the 4th. And no worries about absolute value because they told us. Assume that all variables are positive. So no messing with that. That's kind of nice. All right, 14. Can we simplify that one if we make it one big fraction? Then let's do that first. So 5/3, there's nothing we're going to be able to do there. But, oh, I better write it out before I get carried away here and start talking through it already. All right. So there we go. 5/3 we can't do anything about. But what's 2 minus 3? So we'll have an a to the negative 1. How about the b's? What will that be? B to the 2nd. The c's? Just a c. C to the 1st. I'll put the 1 up there. And now, hopefully, that helps us figure out which numbers, or which letters, I should say, are going to stay up on the top with the 5, and which have to go down to the bottom with the 3. So what stays up top? It does, because those are positive exponents. But the a has to go down below so it can become positive. So now, it's not a new problem. It's the same problem we started with. It's just simplified, which makes the next part easier. Because we still have a radical in the denominator, and that's not okay. But since we simplified that denominator, now it's going to be a little bit easier to figure out what we have to multiply by to rationalize the denominator. Now I know it has to be the cubed root of something, but I'm hoping somebody can tell me what the something needs to be. It does. We've got 1 3 right now and 1 a right now, and we need 3 of them to make this work. So it's going to have to be a 3 squared and an a squared. because then we'll have 3. We'll have an index of 3 for our radical, and then we'll also have third power for everything underneath there. So my next move is to just make sure that my denominator is going to work. And it does. Cubed root of 3 to the third a to the third is 3a. So that's beautiful. And then we have to follow the order of operations up in the numerator. So we have to do this power first. 3 squared is what? 9. 9 times 5. So we get 45, and then let's put those variables in alphabetical order. A squared, b squared, c. Because we reduced this early on, we don't have any reducing we can do here. We just have to write it over our 3a denominator. And that's the best we can do. Now, if you're thinking, but how am I going to know that? Well, then take a second and double check. Cubed root of 45. Grab your power chart. 45 would land right there. Try and divide 45 by 27. Try and divide it by 8. It's not going to go in. So never hurts to give that last try before you move on to the next problem. For a lot of students, that's the toughest problem on this test, right there. So just make your index match your exponents, and then things will cancel out nicely. Because these, how do we multiply stuff that looks like this in number 15? Yeah, FOIL. And this one we don't have to do all of FOIL, do we? How do I know that? What about these parentheses tells me I don't have to do all of FOIL? Yeah, they're conjugates. One's a plus and one's a minus. So yes, we normally do FOIL, but we know outside times outside and inside times inside are going to cancel each other out. So we can shorten up our work here. So 49 minus, because we have a negative 2 square roots of 3 times a positive 2 square roots of 3. 2 times 2 is 4. Square root of 3 times square root of 3. Square root of 9. But there's definitely something we can simplify there. What is it? Yeah, the square root of 9 is 3. So we get 49 minus 12, which is 37. So pretty cool. That's why we did this conjugate thing, remember? So that we can get what's called a rational answer. Rational means you could write it as a fraction, as a ratio. So 37 over 1, that's a nice little fraction. This is the way to get rid of radicals in the denominator of our fractions. All right, 16. You know what I love about 16? I've been wandering around while you guys are doing your work, and so many of you just automatically put the parentheses down twice. I love that. Every once in a while we have somebody who wants to distribute the 2. Can't do that. You can only distribute powers if it's pure multiplication or division in the parentheses. This has a plus. Got to write it down twice. Now this one, we have to do FOIL. And that's because our signs are not opposites in this one. These are not conjugates. So first times first, square root of 121. Outside times outside, plus 3 square roots of 11. Inside times inside, plus 3 square roots of 11. Last times last, plus 9. Light bulb moment. Give me one of them. This is 11. Second light bulb moment. Those two middle ones can be added together. And then finally, we know 11 plus 9 is 20. So 20 plus 6 square roots of 11. Got it. Like I said, these we've just been doing within the last week. So you're probably remembering these a little bit better than that front page. Did I fit another one down here? Nope. 17. You get to 17 and you go blank. You're like, can't I just leave that the way it is? And then you remember, oh, it's got a square root on the bottom. Gosh, I don't remember what you do with that one. Test taking strategy. Turn back and say to yourself, This had square roots. This was how we got rid of them. We used the conjugate. Well, that's what I need to do here. So what's the conjugate of the square root of 2 plus 7? It's exactly what it is. So I'd do the denominator first, just to make sure that everything's going to go well. And all we have to do is F and L from FOIL. So first times first is the square root of 4. Last times last, minus 49. 2 minus 49. And a not so wonderful negative 47. But probably means we're not going to do any simplifying or anything at the end with a nasty little negative 47 on there. And then on the top, we had to multiply 1 times this stuff. Well, that doesn't do anything. Now, definitely would take this as an answer, but as some of you have asked me in the past, you've asked where do we put the negative? We do like to have the negative on the top. Not that this answer's wrong, because it's not. So you could distribute the negative across the top instead. And then, if you wanted to, you could even turn these two around so it looks a little nicer. But I'm taking any of those three for full credit. Any of them. So I would stop here. Just so you don't make a mistake when you're working with all those negatives. So it doesn't matter if the negative's on the top or if it's on the bottom. It just has to be there once in front. Alrighty, number 18. What's up with 2 of these? I mean, we spent a lot of time yesterday going over them if they have 1 square root. Do you suppose we could multiply those together and get 1 square root? Then that's what we need to do. We need to make it look like yesterday's stuff. 27 times 3? We got to multiply similar bases. What do you do with the exponents when you multiply similar bases? You do add them. Well, this doesn't look so bad. What's the square root of 81? How many of those x's are we going to have? We don't even have to worry about absolute value bars because they said assume all of them are positive. So once we get it to look like something we've already done, well, then it's a piece of cake. Number 19. We can only add and subtract like radicals. So I don't know about you, but I'd like to have a place to start. Out of all 3 of these radicals, which one of those is the smallest one? 2 square roots of 3. So the only way we'll be able to do this problem is if 3 divides nicely into these other numbers. Well, let's see. 192 divided by 3. Ooh, we're going to be able to do that one. 27. Well, you already know this one, but 9. Yay! Nice numbers. So, square root of 64 times the square root of 3. Except I just wrote 61 instead of 64. Bless you. Plus 4 square root of 9, square root of 3, minus 2 square roots of 3. What's the square root of 64? Oh my goodness. Must be writing too fast for the smartboard. That did not look like an 8. Square root of 9? What do I do with that 4 and the 3 right in the middle there? Good. Multiply them together. So 8 square roots of 3 plus 12 square roots of 3 minus 2 square roots of 3 is a grand total of what? 18 square roots of 3. And we've got it. So again, educated cheat. You know, this is the square root of 3, so that's simplified. There's nothing else we can do with it. The others might break down nicely into 3s. If they don't, they don't. You know, sometimes we only put 2 of these together in the homework instead of all 3. All right, number 20. Number 20 is one of those problems that either you get it and I see that on the test, or you leave it blank because you totally forget this next minute. So don't forget this next minute. 7/2. Is that reducible? So making this one big fraction is not going to help. We have to figure out what to multiply this by on the top and the bottom, and it has to be fourth root, to get rid of a 2. Now remember, we did one of these before. The index has to match the power. What's the power of this little 2 right now? How many more do we need? 3. And then focus on the denominator. What's the fourth root of 2 to the fourth? Exactly. That's the reason we do that. And then, you'll have a calculator, so you can do 2 to the third times 7, or maybe you do it in your noggin. What's 2 to the third? 2 times 2 times 2. 8. 8 times 7? Again, if you're worried, hey, maybe there's a perfect square or perfect fourth that'll go into 56. Well, grab your power chart. 56 lands there. 27 doesn't go into 56. 8 doesn't go into 56. So it's done. That's as far as we can take that. All right. Oh, did I do cubed root instead of fourth root? I did. Okay, this one. 16 would be our only option. Not working. All right. What do we have? Just one more? Where did I hide it? Did I put it on a new page? I did. That looks like a monster. Ideas. What could we do to make that look like something we've already been doing? Yeah. Multiply it. Why not? Make it one big square root business here. So what's 2 times 7? How about 16 times 5? What do we do with y to the third and y to the 9th when we multiply them? Y to the 12th. Good. So the question is, do we have any nice cubed roots that'll go into 80? Take a peek. Cubed roots for 80. All the way down to 8, right? 8 and 10. And then I'm going to have the cubed root of y to the third, cubed root of y to the third, cubed root of y to the third, cubed root of y to the third. Well, at least it works out all the way. There's no nasty leftovers back there. So what is the cubed root of 8? 2. Cubed root of 10 is not something nice. What's the cubed root of y cubed? Okay, so let's talk about the pretty part. What's the pretty in the front? $28, y to the fourth. And again, they said, assume all your variables are positive. So that one is done. All right, I want you to take a look at the practice test. I could make up another one of any of these, but you know that you have that concept byte and 6.1 to 6.3 review packet. Yours is buff colored for this. Anything you need to ask about from any of those? Any of them you're saying, hey, if she made one more of these, I know I'd get it. So you think with the practice you'll be good? Okay, so the rest of the time will be spent on your little buff packet. And